Yeah, hi guys. In previous video we have discussed about the motion in a plane. Like best example for motion in a plane is projectile motion. We discussed about the projectile motion, oblique projectile motion, and every concept related to the projectile motion, like projecting from a certain height and projection onto the inclination plane, etc. We have discussed, right? In this video we'll discuss about relative velocities, relative motion. Okay, so here in the nature, if you observe carefully, let me have, yeah, whenever, let us take two particles here. For example, let me take a particle here A and here the particle B, right? So here if you observe from here to here, this is nothing but XA, right? And here to here, this is nothing but XB. Okay, so what are they? This is nothing but XA and this is nothing but XB, right? What is XA? XA is the distance of the particle A from origin, right? XB is the distance of the particle from origin, means they are telling position of particle A and particle B. Here whenever you want to study about motion of an object, then you must know its position, right? If you want to know position, you could able to measure the position from the any one reference point. Without having a reference point or reference line, you cannot decide the position of an object, right? Not only position, you cannot decide either object is in the rest or motion. You cannot decide without using the frame of reference or reference line, right? That is why these two terms, rest and motion, these two are called relative to each other. For example, imagine you are in the bus, another co-passenger in the bus along with you, and he is sleeping. You feel that he is in rest with respect to you, but the same person who is outside of the bus observing both of you, he feel that you both are in the motion, isn't it? Here you both are in rest, at the same time you both are in the motion with respect to observer. You are in the rest with respect to co-passenger, you are in the motion with the observer who is at outside. So here rest and motion, they are not absolute, right? They depend upon the observer, right? If the frame of reference changes, then the positions may change, right? So here whenever you measure the any position of an object, definitely you must use a frame of reference, right? So here coming to relative positions, let us see here. This is XA, position of the particle A from origin, XB, position of the particle from origin. Now here if I take this distance, right, from here to here, this distance is called XAB, position of A with respect to B. Okay, now position of A with respect to B, or else I can call this position as this gap as a XBA also, right? Let's see what is XBA. Position of the particle B with respect to A, position of the particle A with respect to B, right? Now let us see here once. Let us see here. Let me have XAB is equals to, what is XAB? XAB is equals to, if you want XAB, then what you have to do? XB minus XA you need to do, right? So actually the relative position formula is XAB is equals to XA minus XB you will get, right? From from XB, if you subtract XA, then you will get XAB. Here you just understand that XAB is equals to XA minus XB, means the position of A particle B is equals to XA minus XB. If you do this, definitely what you will get here from this, you will get a negative, right? Negative value you will get, right? So here means the position of A from B is left side, right, which is called negative sign convention, which we have taken negative sign convention. At the same time, if you want to know the position of particle B with respect to A, that is equals to XB minus XA. Now what is XB here? XB is greater one, and what is XA? A smaller one, right? If you do XB minus XA, definitely you will get positive only, right? Now what this value is indicating, the position of B with respect to A is right side, means which is called positive, right? So here the sign with respect to sign convention, we are getting the position of the A, B part. So from this what you can tell, XAB is equals to XA minus XB, XBA is equals to XB minus XA, right, with respect to directions, right? Now This is motion in one dimensional, right? So now here what you do is you got xab is equals to what is the formula? Yeah, we got here xab is equals to xa minus exb, right? The position of a with respect to b, right? So definitely you will get negative value because the a particle is left side to the b, that is why you will get negative, right, with respect to sign convention. Now here what you do is just you differentiate both sides, then what happens? dxab by dt is equals to dxa bar by dt minus dxb bar by dt. Then what you will get here? You will get if you differentiate this, then you will get the change in relative position with respect to time is called relative velocity ab, right? The relative velocity of a with respect to b, the position of a with respect to b is equals to xa minus xb. Same way, if you differentiate this equation both, then you are getting the relative velocity of a with respect to b is equals to va minus vb, va minus vb. This is in one dimensional, clear, right? So if they give any relative values, for example, just imagine yeah, there are two cars. Let me have there are two particles, right? This is a car a and this is car b. Now it is moving in this direction with a 5 meter per second, and this is also moving in this direction with a 10 meter per second, right? They both are moving in the same direction. Now velocity of a with respect to b, if I do velocity of a with respect to b is equals to va minus vb. What is va? Va is nothing but 5 meter per second minus what is vb? 10 meter per second, right? Now I am getting minus 5 meter per second. Means the person whenever he is in the car b, he is observing car a, then the person in the car b is feeling that the person in the car a is slower than him, right? How much slower he is? 5 meter per second, right? This is what the person b feels. For example, the same example, if I calculate velocity of b with respect to a, now we are calculating the velocity of b and the observer is in a, car a, okay? Then what about it? vb minus va, then you are getting 10 minus 5, that is equals to 5 meter per second. So from this you can tell that you are getting positive value, means the car b with respect to a 5 meter per second faster, right? It is faster than car a. How much faster? It is 5 meter per second, right? This is what observer a, who is in the car a, he feels that this car is moving than this car 5 meter per second extra speed, right? So this is about the relative velocity. For example, one more thing, if both the cars are moving in the same direction, opposite direction, this car is moving 5 meter per second and this car is moving in a opposite, okay, 5 meter per second, then now if you calculate relative velocity of a with respect to b is equals to va is equals to nothing but 5 meter per second minus vb is nothing but minus 10 meter per second, because in opposite direction it is moving, I mean in negative direction it is moving, right? That is a minus 10. Then you will get 5 plus 10 meter per second, then answer is 15 meter per second. So here what he is doing, what happened here, the person b, the observer is in b and we are calculating velocity of a. Now the person who is in the car b is feeling that the car a is coming towards him with 15 meter per second speed, clear? In the same way, if you calculate vba, then what is vba? vba is nothing but vb minus va. Here what happens? Minus 10 minus 5, then you are getting minus 15 meter per second. Now what does it mean? The same way, the person who is in the car a is feeling that the car b is coming backward, coming towards him. In this direction is negative only, right? Left hand side. So the car is coming leftwards. Minus symbol is telling that the car is coming leftwards with a 15 meter per second speed, right? This is about the relative velocity. For example, they can ask you question like this: the gap between these two cars is, let me take it as a 30 meters, right? 30 meters. The gap between these two cars is 30 meters. Then how much time does it take to meet the cars, right? How much time does it takes to meet the car? So now here, since both the cars are traveling towards each other, then what is the relative velocity? The relative velocity of A with respect to B is equals to 15 meter per second, right? Now what is the relative distance between them? This distance is called relative distance. That relative distance is equals to SAB is equals to nothing but 30 meters. Okay, now time is equals to distance by speed, SAB. Okay, distance by speed. Now relative distance by relative speed. What is relative distance? 30 meter by what is it is 15 meter, right? Now it will cancel 2 times, then it takes 2 seconds. It takes both the objects 2 seconds to meet each other, right? Now, so here you should observe one thing. The car A is traveling with less speed than car B. So here, however the speeds they are, but ultimately they both will meet at after 2 seconds they are starting. For example, just imagine here, let me have the car comes here only up to, because it is less speed, right? It comes up to here. This car goes long distance, right? They both will meet here, right? It takes 2 seconds. Clear na? Right? So this is how they can ask a questions on this relative velocity. At the same time, so these and all what we have solved now, these and all relative, independent relative velocities, means they are not depending upon some other frame of reference, right? Independent relative velocities they are. For example, coming to the second type of questions, like dependent relative velocities, right? Dependent relative velocities in the sense, for example, just imagine there is a belt, there is a belt like this there, right? It is moving with velocity v. Means like in the airport and metro stations, you can see that the belt carry the luggage, right? Which is carry the luggage forward. It rotates with the v velocity. So now here, just imagine on such kind of belt, you are on the belt at the velocity with v velocity. This is moving. For example, v velocity in the sense, let me have 10 meter per second speed. It is moving. Then on this belt there is a person, right? On this belt there is a person. Now this person is running in this direction with 5 meter per second, right? 5 meters per second. Now there is a distance of to come to another end. It has let us take 50 meters distance, right? The belt length is 50 meters. Now how much time does it take? Here, if you observe carefully, he is not on the independent frame reference. It is dependent frame reference, means the frame of reference also is running with a certain speed. Now his speed is 5 meter per second plus 10 meter per second. Both you have to add, then you will get a 15 meter per second. So this 15 meter per second is the speed of this person. So from one end to another end, right? How much it is distance? 50 meters. Now he'll take the time 50 meters distance by speed. What is relative speed? 15. Okay, now it takes 3 times and 10 times. So 10 by 3 seconds it takes. Clear na? 10 by 3 seconds it takes to reach this position right now. So at the same time, just let have one more question here. For example, there is a belt like this. Okay, na? There is a belt like this. Now what happened here? The belt is moving with v is equals to 10 meter per second speed. Okay, 10 meter per second speed, and the person is on this side. One person who is moving with a 5 meter per second, right? And another person is here who is moving in this direction 15 meter per second. Okay now, this person is opposing 15 meter per second, he is running in this direction, he is running in this direction. Now here if you observe, if you want to find, this is a person A, this is a person A, and he is a person B. Now the distance between them is like 50 meters, right? The distance between them is 15 meters. The belt is moving, with 10 meter per second speed. Now if you want to calculate velocity of A with respect to B is equals to VA minus VB, right? Here what is VA? You should remember that you should not give VA is equal to 5 meters per second. VA is nothing but 5 meter per second plus 10 meter per second. Then VA is equals to 5 meter per second, means it is a 15 meter per second, right? What is VA? 50 meter per second. At the same time, what is VB here? Very important question it is, right? So now what is VB? VB also is nothing but VB is equals to nothing but it is about 15 meter per second. Is moving in this direction with 50 meter per second. You take minus 50 meter per second and 50 meter per second and then plus 10 meter per second. They both are in opposite direction. Very simple, right? Now what about it is minus 5 meter per second. What is the minus 5 meter per second? Velocity of the person B, right? Now here VAB bar is equals to VA bar minus VB bar. What is VA you got here? 15 meter per second minus 5 meter per second, minus 5 meter per second, right? Now you will get 15 plus 5 meter per second, then it is nothing but 20 meter per second. So what it is? The relative velocity between these two people, is 20 meter per second. Now here this is how you have to calculate, okay na? You should remember that. And now here, then after how much time they both will meet each other? Like it's like time is equals to relative speed, relative distance between them by relative velocity. Now SAB is equals to 50 meters by 20 meter per second, right? Means 5 by 2 seconds. After 5 by 2 seconds they both will meet each other, right? Like that you have to calculate the relative velocity, or whatever the question, according to the question you have to solve the problem. Hope you understand well, right? Now coming to the next, so up to now what we have done, we have taken about the let me have white, yeah. Now VAB is equals to VAB bar is equals to VA bar plus VB bar. See, you must remember that these two are the questions comes under these two are the question which comes under like what we call relative velocity, dependent relative velocity. These two comes under dependent relative velocity, okay na? And next, yeah, now you got what is relative velocity of A with respect to B is equals to velocity of A, sorry I wrote here minus, right? Yeah, velocity of A minus velocity of B, right? This is the relative velocity formula. Now again you differentiate both sides, then what happens? dVAB bar by dt is equals to dVA bar by dt minus dVB bar by dt, right? Now what happens here? That is equals to VAB, in the sense acceleration of A with respect to B bar is equals to acceleration of A bar minus acceleration of B bar, okay na? Acceleration of A bar minus acceleration of AB bar, means the relative acceleration of A with respect to B is equals to acceleration of A minus acceleration of B. These are absolute values, right? And now here, based on this, they'll give you many questions, right? Whenever, and you one more thing you have to remember, whenever relative acceleration is constant, okay now, whenever this relative acceleration is constant, then you can use V relative VAB is equals to, directly I will write V relative, I write VAB, okay, VAB is equals to UAB, U plus AT, right, AAB into T. You can use this formula. Means what is UAB? Initial relative velocity of A with respect to B. What is AAB? I mean VAB, final velocity of A with respect to B. What is AAB? Acceleration of A with respect to B, right? Time, right? And next, same way, SAB bar is equals to UAB bar T plus half AAB bar T square, right? And likewise, we can use all the formulas. V square minus U square is equal to 2S. VAB square, V square minus UAB square, V square minus U square is equals to 2A. Yes, S also is nothing but relative distance between the two particles, relative displacement between the two particles, right? So by using these equations, so what you can do solve any problem. Particularly you can substitute these equations while freely falling body. For example, when a body is falling from a certain height, at the same time simultaneously another body is projected upwards, right? In these kind of situations you have to use these equations, right? Then you can easily solve such kind of problems. Of course, after completion of the entire topic, we'll solve the problems also. From this top 50 problems we'll take, and we'll solve those problems here, right? So this is about the relative velocity in one dimensional. Clear? In one more thing also, like river board problems. One dimensional river board problems also comes under one dimensional problems only. For example, if you observe here, for river boat, right? River boat problems. Here, just imagine a river is flowing down in this direction with 5 meter per second, or else let me take V meter per second, right? VR. What is VR? Velocity of river, right? And here a boat is, this is the boat, okay now, this is the boat. The boat is moving in this direction with VB, right? Now here the relative velocity of boat with respect to river is equals to VB minus VR, right? So what is VB minus here? Here it is, this scenario is called upstream. Means whenever the boat flows opposite to the river flowing, then it is called upstream. Then the relative velocity of B with respect to river is equals to VB minus VR. What is VB minus VR? This is the velocity, exactly, this is the relative velocity exactly which appears to the person who is on the ground, right? So who is on the ground, this is the velocity which is appears to the person, right? At the same time, for example, they have at the d distance there is a target. How much time does it take to reach the target? Here target is strong, it is not moving right now how much time does it take to reach the target? Then what will take? Time is equals to a distance, right? From here to the distance is d, distance by the distance by speed. What is speed here? VBR you have to take, okay na? Likewise you have to take. And next, do remember sometimes there is a cork in the river, and then after how much time it will reach to the cork. You should remember that whenever cork in the river, any floating object is in the river, then it will also move with the VR speed only. You should remember that, and you have to find out the time. So if it is moving, then how much time it will take? Here the relative velocity of cork with respect to boat you have to find. So I said na, it is comes under dependent frame of reference, right? So in this case what you will do is, the cork is moving with VR velocity VC. Just imagine, so VC is nothing but VR only, because whatever the river flow is there, with the same flow the cork also will move forward, and it is coming in this direction with the velocity of VBR, right? Now after how much time they both will meet, the time taken, I mean here you should take velocity of cork or velocity of river with respect to velocity of boat with respect to river. You have to take. Now here VR minus VBR, VR minus VBR, right? So you have to take this, then this is the relative velocity, and then time taken is equals to, if the distance between them is, between the cork and the boat is d, then d by VR minus VBR, right? If you go further, VR, cork speed is also VR minus, what is VBR, Nana? VB minus VR, right? Minus of minus plus, then 2VR minus VB. This is the relative velocity, right? So this formula you have to substitute here, then you will get how much and does it take to meet both of them, right? Similarly, many problems they'll ask in the upstream, you have to measure. And next, coming to the downstream, if you observe carefully, coming to downstream, see, it will be downstream, or they use one more word is nothing but current of the river is, they use this word also, you don't forget that. Now coming to here, a boat is moving in the river, right? Just imagine the boat is moving in the river, right? Here the boat is moving along the velocity of VB, right? And the river also is flowing in the same direction with VR. This is called downstream. Now here the relative velocity of VB with respect to river is equals to VB minus VR. Now if you substitute here, since it is a downstream, right? Since it is the downstream, you will get here positive. Of course, this is but here, I mean, downstream velocity is plus VB R is equals to VB plus VR, because it is a downstream, right? Now, so that you, because the river speed helps to boat, right? So now the relative velocity of B with respect to river will be VB plus VR. This is the velocity which appears to person on the ground, right? So similar kind of questions also will be asked on this content also, right? So now with this we have completed relative motion in one dimensional, right? Next, let's go with a new page, right? Next, let us take let us discuss the content which is relative motion in two dimensional. Now let's imagine we have an x-axis here and a y-axis like this, right? So now here, just imagine we have two particles. A particle is here, particle A, and this is initial, I mean, this is the particle A, and let us have one more particle B here, right? A and B. Now if I draw position vectors, we have already discussed about this in the starting of this lesson, right? This is initial position vector, and the from same point this is this is the position vector of particle A, right? What is this? RA bar, and this is nothing but RB bar. And now here, if I draw a vector from where to where, two colors I use here, right? Here to here. So what it is, this arrow is indicating nothing but position of, this arrow is indicating nothing but position of R, position of A with respect to B. That's why from B to A it is, right? Position of A with from B, so position of A with respect to B, this is RAB. At the same time, if I take one more if I take one more arrow from A to B, if I take one more arrow from A to B, what it is telling here, this is a position of B with respect to A, right? Lot of difference is there right now. So now here, if you take RAB bar, position of A with respect to B, you observe RAB is nothing but, let me have with the white, okay? Now let me have with white. So what is RAB bar here? RAB bar, okay, RAB bar is equals to position of A from B, right? How can you write? If you observe this triangle, you can apply a triangle law of vectors. What is that? If two vectors are represented with the sides of the triangle, then the third vector which is closing the triangle gives the resultant, right? Tail to tail and head to head. Here if you observe, RA is tail to tail, head to head connection, right? Now so what you can write is, to find out RAB, what we are doing is we are applying a triangle of vector in this vector. Now what is RA bar? RA bar is nothing but RA is the vector which is closing tail to tail and head to head in this triangle. That is why RA bar is equals to RB bar plus RAB bar. Okay na? Now from this what you can write? RAB you will find out, right? RAB bar is equals to RA bar minus RB bar. You send this RB bar this side, then RA bar minus RB. So this is the relative position of A with respect to B. Relative position of A with respect to B, by using the triangle of vectors we got RA minus RB. Clear na? In the same way you can calculate the position of B with respect to A also, right? So if you observe what is tail to tail, head to head, see, for RBA, for red, RA and RBA, RB. So here RB is tail to tail, head to head. If you consider here red arrow, right, red vector, then you can write from that RB bar is equals to RA bar plus RBA bar, right? From this what you want, RBA bar you want, right? RBA bar is equals to RB bar minus RA bar. So by using these equations you can find out the position of one particle with respect to another particle in the coordinate system, right? Now so now here you should remember one thing. If you if you differentiate this equation both sides, then what you will get? Then DRAB by dt is equals to DRA bar by dt minus DRB bar by dt. Now from this you will get DRAB by dt in the sense relative velocity of A with respect to B in a plane is equals to velocity of A with respect to origin minus velocity of B with respect to origin. This is the formula which you want to use to find out relative velocity in the plane, right? To find out relative velocity. At the same time, where is my mobile? Yeah. At the same time, what you do is, again if you differentiate, excuse me, if you differentiate this again, what happens? Let me have some charge. If you differentiate this again, okay, then you will get here, again differentiate both sides, then you will get, directly I'm writing acceleration of A with respect to B is equals to absolute acceleration of A with respect to origin minus acceleration of B with respect to origin, right? This is also formula you can use. And again, as I said before, if AB bar is constant, then what you can do, you can use all the four equations, right? All the four equations you can use, and you can find out. How can you find out? For example, v square minus u square is equals to 2as VAB square bar VAB UAB square bar 2AB SAB, right? So like that you can use equations of motion, and you can find out what are the physical quantity relatively you want, right? So and next, for example, let's do a small problem by using a two-dimensional motion, right? A small problem will do. So here if we observe, just imagine we have a road, right? The road is like this, and it has four vehicle, I mean four way, right? So this is the road. Now a vehicle is coming in this direction with a 5 meter per second speed, okay, or else let us have the value which is convenient to calculate. Just imagine the car is coming in this direction with a 4 meter per second, right? And here one more car B, this is the car A and this is the car B, and car B is moving in this direction with a 3 meter per second. With 3 meter it is moving, with the 4 meter per second it is moving. Now here the question is, and what is whenever the person A in the car the person in the car B is observing the car A, then how does he feel? How does he feel, right? Now means the velocity of car A with respect to B we have to find out. What is formula? VA bar minus VB bar. VA bar minus VB bar, right? Now so what is VA bar here? 4 meter per second. What is VB bar here? 3 meter per second. Then what immediately you will do? 4 minus 3 is equals to 1. That is wrong. Here they are not along the same direction, opposite. They are perpendicular to each other. Now what is relative velocity here? If you get VA minus VB, then you have to use VA square plus VB square minus 2VA VB. Okay, 2VA VB cos theta. Okay, na? 2VA VB cos theta. By using this equation you can able to find the relative velocity, because here minus is there na? That is why you will get here minus, right? You know this already from what we call parallelogram law of vectors, right? So now what happened here? The angle between these two velocities is 90 degree, so that cos 90 is 0. This term becomes 0, and 4 square means 16 plus 3 square means 9. 16 plus 9 is 25, means 5 meter per second. What is the relative velocity of A with respect to B? 5 meter per second. Now here, okay, you found relative velocity. Now what is matter? Direction is matter, right? Now let us have, if I draw with vector shape, I'll explain you. You will feel it very happy, right? Now here if you observe carefully, oh, yeah, so now here let's have vector shape, right? So imagine what is this? 4 meter per 4 centimeter, right? 4 meter per 4 meter per second, right? In this direction A is moving. And what about VB here? VB is moving like this with how much? 3 meter per second, right? Now so now here what is, let me draw the velocity vector for this is 3. Yes, this is 3. Now this is nothing but what it is? This is nothing but VA bar, and this is nothing but VB bar, right? Now so now here we want to find out VA, velocity of A with respect to B, right? Velocity of A with respect to B is equals to, sorry, yeah, velocity of A with respect to B is equals to VA bar minus VB bar. VA bar minus VB bar. Now here what is VA? And I can write this like by using I want to apply triangle of vector na, that's why I will write it VA bar plus of minus VB bar. Clear? So because I want to add these two vectors, one is positive vector, another one is negative vector, so plus of minus minus, I'll get the same result of what I want, right? So now here what I'll do is let me check, either it is, yeah, it's recording only, yeah. Now what I'll do is VA, right? VA in the sense same 4 centimeter, okay, yeah, this is VA, in which direction it is same as I have drawn here. And VB here, VB is minus is there, that is why I will take negative, downwards. VB is downwards. From this it is how many? 3 kilometers, right? Downwards, right? Now these two are two vectors, and now what is the resultant of these two, which is connecting them? Tail to tail, head to head. So tail to tail and head to head, exactly 5 came, right? sorry, exactly 5 km, means this is with respect to vector also VE, this is VA and this is minus VB. What is this? This is the resultant of VA and VB, I mean VA with respect to B, means in which direction arrow is? In this direction. So it means that you observe carefully, the resultant is in this direction, right? The same thing I will draw here, so with the 5, okay na, with the 5 right now. So here this is the resultant we got, right? What does it mean? VAB we calculated. It means that the car A is coming in this direction with respect to B, means the person who is in the car, he is feeling that this car is coming towards him in a straight path like this, okay na? This is what he feels. Clear? Yes, this is about the relative velocity in two-dimensional motion. So this is how you have to calculate the problems by using this. And once again the same thing, right? Hope this example is quite enough to understand the relative velocity. And next here same as like just before, what, how we have done, the same way, VAB bar is equals to VA bar minus VB bar. Now what you do is you just differentiate both sides, then what you will get? You will get acceleration of AB bar, means acceleration of A with respect to B is equals to acceleration of A bar minus acceleration of B bar, right? So if same like just before, right, if AB bar is constant, what if AB mean acceleration of A with respect to B is a constant, then what happen again? You can use any 4 equations are there in motion. S is equals to ut plus half a t square. SAB is equals to UAB half AAB. Okay na? In the vector shape you can use this equation to find out relative position or relative initial velocity or else acceleration, right? Like that. This is one example, right? One formula I gave. You can use all the 4 formulas: v square minus u square is equal to as, s is equal to ut plus half a t square. So all of them you can use, you can solve the questions, right? Hope you understand about the two-dimensional relative motion. Next, coming to the next one, we'll discuss about like rain boat problems. We'll discuss, which are very important. Okay, rain umbrella, yeah, rain umbrella problems we'll discuss. Okay, coming to rain umbrella problems. So here just imagine this is the cloud and the rain is falling vertically. First example. So we'll solve the rain umbrella problems. Okay na? So here if you observe carefully, the rain is falling vertically. How it is? Oh, it is straight line. We don't know. Yeah, the rain is falling. This is a vertical line. This is vertical line, right? And next this is horizontal, right? And this is vertical line. Right? So now here this is vertical, and also just imagine the rain is falling vertically, okay na? So now here the rain is falling vertically. Okay, let me have arrow mark here, then let me have arrow mark, and the color is yellow. Okay, so the rain is falling vertically, right? The rain is falling vertically, and what are red dot line? It is indicating the vertical. Okay, so now the rain is falling vertically. The velocity is VR. What is the velocity of rain? VR. VR is the velocity of rain. And here there is a person. I mean, he is moving in this direction with the velocity of men, right? VM is what? Velocity of men in this direction, right? He is moving in this direction, VM. Now here we are going to find out velocity of rain with respect to men, right? So if you find that, excuse me, yeah, So if you find this velocity of rain with respect to men, then we can know how to hold the umbrella in order to protect from drenching of rain. Okay, so vrm is equals to vr bar minus vm bar, right? vrm is equals to vr bar minus vm bar. So now by using a triangle of vector, we can solve this, right? What is vrm here? vr bar plus minus vm whole bar, right? So now here what you can do is you apply this to the triangle of vectors, right? By using triangle of vectors law, we can easily solve it. Now just have what is here? This is nothing but what? It is nothing but vr. Okay, na? I have drawn vr as they have given. This is nothing but vr. Okay, it is vertically falling down. The rain is falling vertically down. And next, minus vm. Actually, what is vm here? This is vm, right? Here to here, this is vm. Okay, this is the velocity of men. But here, what is there? Minus vm means you have to take it from in exactly opposite direction. Same length, exactly opposite. Okay, na? So now here, if it is vr, this is nothing but vm. And what about this? Minus vm. Now what is the resultant here? The resultant is nothing but tail to tail, head to head, right? Tail to tail, head to head. This is the velocity of a rain with respect to men, right? This is the velocity of rain with respect to men. And here what you have to do is you have to hold the umbrella. You have to hold the umbrella in this direction such a way that you can escape from the drenching of rain. Okay, whenever the rain is vertically falling down and you are running with vm velocity of men, right, in this direction, then what you have to do? You have to hold the umbrella in this direction, the resultant direction. Then you can escape from the, this is the alpha, right? Now from the diagram, tan alpha is equals to opposite, means vm by opposite by adjacent vr, right? Alpha is equals to tan inverse of vm by vr, right? So this is the relative velocity that you have to hold umbrella so that you can escape from the drenching of rain. Clear, right? This is the case 1. And next, coming to case 2. What is case 2? For example, just imagine the rain is not falling vertically down, right? Just imagine the rain is not falling vertically down. So this is cloud, right? Now, and now here the references line I'll draw, right? So what is first reference? This is vertical line, and this is horizontal, I mean the person who runs, right? This is horizontal. Let me take directly, yeah, this is on the run, right? Now here the person is running. Just imagine the person is running. So the man is running in this direction with vm velocity. This time the rain is falling like this. It is not falling vertically down. So this is the velocity of rain, right? This is nothing but velocity of rain, right? And it is making an angle theta with vertical, right? It is making an angle theta with vertical. Then here the man is running with very less velocity. Just imagine he's not maintaining that much of velocity. Now what we want? Velocity of rain with respect to man. If you know this velocity of rain with respect to man, then we can know how to hold the umbrella, right? So now velocity of rain with respect to man is equals to vr bar minus vm bar. This is the velocity of rain with respect to men. So now from this, what you can do is you can write vr bar plus half minus vm bar in order to apply the triangle of vectors. You can, in order to apply that, you can write like this. This is nothing but vrm, velocity of rain with respect to man, right? So now here let's apply the triangle of vectors. How can you do here? Just imagine let me draw first rain, right? The rain vector is making angle theta, right? This is the rain. Oh, sorry, this is nothing but velocity of rain. Okay na? This is nothing but velocity of rain, and what it is doing, it is making angle theta with vertical. So this is vertical. Okay na? With vertical it is making angle theta. And here, what about men velocity? It is making angle theta with vertical. And what about men velocity? Let me have men velocity with yellow color, right? So here to here, or else what I can do is, men velocity is nothing but, actually the rain is falling vertically by making angle theta, and the men velocity, this is men velocity, right? This is men velocity, very less speed is running, right? So this is the less length I have taken, and what it is nothing but velocity of men. Now here, according to formula, what we have to do, minus Vm. What is that? If it is plus Vm, then what is minus Vm? This is the minus Vm. In minus Vm will be in opposite direction, right? So this is the minus Vm. Yeah, this is nothing but minus Vm, right? So now this is minus Vm. Now what you can do, you can find these. Vr is one rain vector, Vm is men vector. Now what is relative velocity? I mean here, what is relative velocity? Tail to tail and head to head, right? Yes, exactly. Not, I'll take this in another color. Because to have clarity, let me have blue color. Okay, so if you take tail to tail, head to head, this tail to tail, head to head vector will give you this vector, will give you, okay, now this vector will give you nothing but velocity of rain with respect to men. Now this is the angle alpha, which you have to hold the umbrella in order to escape from the drenching, right? You are moving with, see, the rain is falling in this direction, you are running with very less velocity, so you feel that the rain is still hitting your back. This is the resultant. Okay na? So what is resultant here? The resultant is like this. This is the resultant. Okay na? The blue one is the resultant one. So still you feel the rain hits you back. Understand? So now this is the, if you draw here angle alpha, right? What is this? This is the alpha which you feel. Okay, this is the alpha which you feel. You have to hold the umbrella. Okay, this is the position of umbrella that you have to, in order to drench from the, right? So now here the thing is, what, how do you measure this alpha, right? Here this is VR, right? Now what you can do is, you can split the VR into two components, right? One component is, let me have this, right? So this VR can split into two components. This is one component, and this is one more component. Two components you are splitting. Okay na? So this if it is, see, the velocity is making angle theta with the vertical, right? So it is making angle theta. Then this is nothing but VR sin theta, and this is nothing but VR cos theta. So now you want, from this right angle triangle, if you observe this, from this right angle triangle, tan alpha you have to measure. So tan alpha is equals to, here to here is VR sin theta. Opposite sides are equal na. So here to, see, exactly here to here, right? The same, here to here is nothing but VR sin theta. Now you want only this value from, so that what you will do, from VR sin theta, if you subtract Vm, right, from VR sin theta, yeah, from VR sin theta, if you subtract this Vm minus Vm, then you will get this x value. Okay na? For which triangle? For this triangle, right na? So now from this, tan alpha is equals to opposite by adjacent. What is adjacent? VR cos theta. So means tan alpha is equal, so what is x here? VR sin theta minus Vm by VR cos theta, right? This is the alpha which you have to hold the angle, which hold the umbrella by making, in order to drench, in order to escape from the drenching. So this is about if you are moving with very little velocity. Now just imagine the same thing. What I'll do is I'll copy. Here it is. The first thing I need to do is, now I'll copy here, right? I entire copy this. Now what I'll do is very simple. It takes very less time for me. Yes, right? I'll copy this. Right, and now what I'll do is I'll paste this here. Here I will paste. Okay, exactly. So now here, if you observe carefully, just in the first case, what happened? The man run with very less velocity. Now he increased his velocity. The man increased his velocity. Now arrow mark also, the size of arrow mark also will be increased, right? Now in this condition, if I draw the okay, in this condition, if I draw the again triangle of what it is here, this is nothing but VR. Okay, na? This is nothing but VR. And what is vertical here? This is vertical, right? This is vertical. This is vertical, and this is VR. What it is? VR, velocity of rain. Now here, what is the velocity of men here? The velocity of men is this is the velocity of men. Okay, na? It is somewhat greater now. Before he ran very slowly. Now what happened? He increased his speed. So such that what happened now? Here when he increased his speed, he started to feeling that the rain is falling vertically down. Means if it is Vm, if it is Vm, then what is minus Vm according to from this formula? What is minus Vm? Minus Vm is nothing but this is opposite vector, exactly, right? So these two are same. This is minus Vm. This is minus Vm. Now what happens now? This now here exactly what is from this triangle. If you apply the triangle of vectors, then what is the resultant? The resultant is, this time I'll take yellow one, right? So tail to tail, head to head. This is the velocity of, what is the yellow one? Velocity of rain with respect to men. Here what the man has done, he just increased his speed, then he is feeling that the rain is falling vertically down. Actually the rain is falling like this by making angle theta, but when the man is running with a certain velocity, then he is feeling that the rain is falling vertically down. Here if you observe carefully, what is this, Rana? This is the component of VR sin theta, the rain component, horizontal component, and what it is? VR cos theta. Here if you observe carefully, the men velocity became equal to horizontal component of the rain, right? So when the men velocity becomes equal to horizontal component of the rain, then the men feels that the rain is falling vertically down. The rain is falling vertically down. Now what you can do? You can hold the umbrella in this, right, by vertically, then you cannot able to drench in the rain, right? So what is the condition? The rain is falling like this, but since the man increased his velocity, horizontal velocity, how much he increased? He increased his velocity such that his velocity became equal to horizontal component of the rain, so that what happens? He cannot he feels that the rain is falling vertically down. Okay, Clear? This is one condition. This is the second condition. Now from this here, if you want to find out anything, for example, if you want to find out velocity of, you can use a right angle triangle, right? Means Pythagoras theorem you can use, you can find out whatever you want. For example, VR square is equals to root of VRM square minus plus VM square. You can use Pythagoras theorem, whatever you want, you can able to calculate here, right? Now this is the condition, you must remember that. So whenever a person is running with horizontal velocity of the rain, then horizontal component of the rain, then he feels that the rain is falling vertically down, right? And next, third case, let's say that the person is increased his velocity even more, okay, even more he increased his velocity. Now here in this condition, the same he increased his velocity even more, right? Now let's same thing. See, what is yellow one? Yellow is the nothing but when the person is exactly increased his velocity, which is equal to, right, this is the velocity of rain. When the person increases velocity equal to horizontal velocity of the rain, right? Now coming to third case, furtherly he increased his velocity, like for example, just imagine, let me have vector. This time the vector is like with white only will take, right? So this is the relative velocity of rain, okay, this is the relative velocity of rain, and this is the velocity of men. He is moving with much velocity, okay, this is the velocity of rain and this is the velocity of men. Now what happened here? If you want velocity of relative velocity, Vrm is equals to Vr minus Vr plus of minus Vm, right? If it is Vm, what is minus Vm? The minus Vm is in this direction, okay, now the minus Vm is in this direction. Clear? Yeah, this is minus Vm, this is nothing but minus Vm. Now what is the resultant? What is vertical here? Let me draw the vertical also. What is vertical? Exactly, this is the vertical, okay, right? This is the vertical, and now here this is Vr and this is minus Vm. Then what is the resultant? Tail to tail, head to head. Let me have red color, right? Tail to tail and head to head. This is the resultant velocity, okay. What it is? This is the resultant velocity of rain with respect to men, okay. This is the, now here actually when we are traveling in a car, even though the rain is falling like this, when you are traveling in the car with maximum speed, then you feel that the rain is coming and hitting your mirror, right? Now front mirror. So means you are having maximum velocity, much velocity compared to rain. Here if you observe carefully, this Vr can split into two components, right? What it is? Vr, the rain is making angle theta with vertical, right? With vertical, then this is Vr sin theta. So if it is Vr sin theta, this also same, here also is nothing but Vr sin theta. Now if you want to find out this angle, what is this? Is alpha. With what angle that you have to hold the umbrella, right? So if you want to find out alpha, then what about here? Tan alpha from this triangle. Can you guess this distance is? This distance is total is Vm, right? This distance x is equals to nothing but Vm minus, you have to subtract this Vr sin theta, then you will get this x, right? X is equals to, from the total is Vm, from that you subtract this, then you will get this. So now from this you can calculate that tan alpha is equals to x by opposite, right? Opposite by. So what it is here, this is Vr, right? Then what about this? This is Vr sin theta and this is Vr cos theta, right? Opposite by Vr cos theta means tan alpha is equals to x in the sense Vm minus Vr sin theta by Vr cos theta. So by using this formula you can find whenever the person is moving with maximum velocity, then the angle which he could able to hold, right? If you want to find anything here, you can use Pythagoras theorem. Hypotenuse square is equals to side square plus side square. You can use that formula and you can able to find out, right? Clear? Hope it is very clear, right? These are the things we have discussion now. And next, coming to a relative velocity, right? So coming to relative velocity, yeah, right, hope it is very clear the concept. So here what is the final we got here? Red one is nothing but a vector. This is nothing but when the man increases his velocity. So this is the velocity of rain. If you run with a somewhat slow speed, then this is how the rain appears to you. If you run with the velocity which is equal to horizontal component of the rain, then this is how the rain appears to you. If you even increase more further, then this is the velocity that rain appears to you. Okay, clear? This is about the relative velocities. And next, coming to river boat problems. They are very easy, and even just 3 cases we solve those 3 cases. Okay now, just imagine there is a river. Like this, right? This is the river. Right, this is the river, and here what you are doing is just you are crossing the river, right? Here the width of the river is, this is the width of the river, right? This is the river. You are on the you are on at the one side of the bank, which is at point A, and here you are at the another, I mean you have to reach the point B, which is exactly opposite to you. Here width of the river is L is the width of the river. Here this is nothing but velocity of let me have with white, we'll use them, right? We'll use this, and here this is nothing but chalo. So this is nothing but velocity of a river. Okay na? And here we are in the sense nothing but velocity of river, and then here this is nothing but velocity of boat with respect to river are in the still water, both same. Okay na? What it is nothing but velocity of boat or swimmer with respect to river, right? Velocity of boat with respect to river or velocity of swimmer with respect to river is nothing but, you remember that, velocity of boat with respect to, okay, velocity of boat with respect to river, right? So now here actually the river is, this is the effort of the river, I mean the effort of the boat or effort of the swimmer. Actually the swimmer is trying to move in this direction always, but here river velocity VR means the river will drift you, it will push you, right? You are trying to move in this direction, right, in this direction, but the river is moving in this direction. That means the river is pushing you. Because of this, your resultant velocity is, this is the resultant velocity. Okay, remember that this is the resultant velocity, means the velocity of the boat. What it is? This is nothing but velocity of the boat. Actually, if you observe carefully, you can draw this like this, the resultant of these two. Okay na? What is that? This is the resultant of, what is this? VB is nothing but resultant of VBR plus VR. Yeah, what is VB? Velocity of swimmer or velocity of boat. This is the velocity which appears onto the person who is on the ground. Okay na? Actually here the VBR is making angle theta with vertical. Okay na? So now what is VB? VB is the resultant of VBR plus, okay now what is VB? VB is the resultant of VBR plus VR. So from this you can write VBR is equals to VB bar minus VR bar, means velocity of boat with respect to river. Okay na, clear? So now here you should remember that in the river boat problems, what is VB here? I'll draw here, right? I'll draw, you check once. So from here to here, this is what VB, velocity of this is nothing but velocity of a boat with respect to river, and this velocity of boat with respect to river can able to split into two components, right? What is that? Those components, one is in this direction along, I mean horizontal to the river, and one more is in this direction. Here it is making angle theta, right? Then here this is called VBR cos theta, and this is called VBR sin theta. Okay, clear? VBR cos theta, VBR sin theta here. And what is river velocity? The river velocity is in this direction, right? I will draw that also here. Now if you have, this is VR, right? So first case you have to remember, this is VR. First thing you have to remember is to cross the river. The only velocity is helping you is called VBR cos theta. Here the width is L, so that is why the time taken to cross the river is equals to width of the river by velocity along with the river. What is that velocity? VBR cos theta. VBR cos theta. This VBR cos theta only is the velocity which is helping you to cross the river, not this one or not this one. Okay na? So by using this you can able to find out time to cross the river. And next, second point that you have to remember is, for example your this VBR sin theta. What is VBR sin theta? One of the component of your effort, right? If this VBR sin theta is exactly opposite to the river, right? If this VBR sin theta is equals to VBR sin theta is equals to VR, then what happens? Exactly you will reach to the opposite to the B. Okay na? Because the river, you are opposing exactly the river velocity, means your drift becomes zero, right? This is the condition for drift becomes zero. And one more important point is the third one. If VR is greater than VBR sin theta, then what happens? You will reach in this direction. Okay na? You will drift in this direction. If it is a opposite point, from here you can drift like this, you can come here, like, because the VR is greater than your one of your component, that is what you will reach here. And next one is, you guess already this, right? So if VBR sin theta is greater than river, then what you will do? You will reach left side. Okay, you will reach to left side. You will reach from here to this side. The drift will not. This will be you will reach this point. Okay na? So these are the conditions you apply according to the question, right? Now here, what is drift here? Drift is nothing but horizontally how much distance you have traveled. Here see, what is your horizontal distance from this diagram? If you observe carefully, here you have started, and right here you reached. Here if you calculate this distance, horizontal distance x, this is nothing but drift. Okay na? This is nothing but drift. What is drift formula here? Drift is along with x-axis na? That is why you can use drift is equals to x is equals to horizontal speed. Who is helping you for the drift? If you observe carefully, who is helping you to reach here horizontally from B to C? From B to C, who is helping you? Nothing but VR minus VBR sin theta. Okay na? Did you understand? So because of the velocity, what is that? VR minus VR minus VBR sine theta. Because of this velocity, you can able to move in this direction. I told you there is a drift if VR is greater than VBR sine theta. Then from the VR, if you subtract this VBR sine theta with whatever the velocity is there, with that velocity he'll reach opposite direction, right? So I mean another side of the bank. Now x is equals to VR minus VBR sine theta into time taken to reach another side of the bank, right? So this is the formula for drift, right? So now drift is equals to VR minus VBR sine theta into what is T? L by VBR cos theta, right? So this is the formula for the drift. This is the time, this is the formula for the time, and this is the formula for the, right? This is the formula for the drift, right? This is the formula for the drift. Now here condition 1, what the condition is, he will ask you shortest time taken path, right? The condition 1 is he'll ask you to, you have to reach the, you have to cross the river in shortest time taken path, shortest time taken path. Now what I'll do is I'll take okay, I'll draw once again. Okay, I'll draw once again. Here just imagine I have a river here like this. This is the river, right? And the river width is L, and the river width is L. Now here what you are doing is, condition 1 is, the case 1 is, you have to cross the river in a shortest path. If you want to cross the river in a shortest path, first you will consider shortest time taken, right? If you want to cross the river in a shortest time taken path, then you should shortest time, right? What is time formula actually? Time formula is equals to L by VBR sine theta, sorry, VBR cos theta, right? VBR cos theta. This is the formula for time taken to cross the river. If you wanna cross the river in the shortest amount of time period, then this cos theta value should be minimum. Means when the theta is equals to 90, I mean not 90, this cos in this function, if the t value should be minimum, then cos theta value should be maximum, because reciprocal na. So from this you can tell that if t value is minimum, then what happens? Then cos theta value should be maximum. What is the maximum cos theta value? It is 1. Cos theta is 1 in the sense theta is equals to 0 degree. Means you have to cross the river, you have to cross the river by making angle 0. Means you have to cross the river in this direction exactly. Okay na? So in this is your effort. What is that? This is your effort, velocity of a boat with respect to river. Means for example, if you try to cross river like this, what happens no? You have to oppose the, this is river flow na, right? This is your effort. Then what happen here? You have to oppose the river. So to oppose the river, it takes much time. At the same time, if you try to move in this direction, if you try to keep your effort in this direction, what happens? Already river velocity is in this direction, so you are trying to move in this direction, then the river velocity will help you to go more further. So then what happens? You need to travel long distance, then it takes long time. So that is why what you have to do, you have to travel exactly opposite. Always you face your head towards the opposite direction. Then what happens? You know, you'll go forward, then the river drifts you. Again you go forward, the river drifts you. Again you go forward, the river drifts you. Again you forward, the river drifts you. Again you forward. Your head is always towards opposite direction. Then you will finally reach to the another point of the another side of the bank. In this way you will have very less drift. At the same time, you are not opposing the river velocity, and here the river velocity is perpendicular to your velocity. Then it's never change your effect, because you know already work done is equals to Fs cos theta, right? Here the angle between these two velocities is 90 degrees. Cos 90 is 0. So work done on you is 0. The work done by the river on you when you are perpendicular, it is 0. That is why, because of that, you don't have to face much effort, so that you can easily reach to the opposite in the less amount of time. Hope it is very clear, right? So here, if your VBR is always towards opposite direction, then what is the resultant? The resultant will be here to here. Clear? So this is the resultant. Right now, this is nothing but this yellow. This one is nothing but velocity of boat which appears onto the ground. Okay. Actually, what is velocity of river? This is velocity of river. If you see here, this is velocity of river, right? And this is VBR, and this is VB. So in this way, if you travel by keeping your head always, because here theta you got 0, right? What you got here, theta value you got 0. That is why you have to head always towards opposite direction. That is the meaning of theta. Here the theta is with respect to vertical. Do remember, in the examination they'll give you theta value with respect to this is the river velocity, right? And this is your velocity, right? Sometimes they will give you velocity of boat with respect to river. They'll give this angle with river, they give you, not with vertical. So carefully you have to observe and you have to solve. So this is the condition for the least time to cross the river. Okay. And here you can use Pythagoras theorem also. Hypotenuse VB square is equals to VBR square plus VR square. This is nothing but river velocity VR. Okay na? So you use Pythagoras theorem here to solve this kind of questions, right? And next one more condition is crossing the river in a shortest amount of time. If you want to cross the river in a shortest amount of time, what you have to do? See, here you can use Pythagoras theorem. You don't forget that, right? Let me tell you then, or else VB square is equals to VBR square, okay, VBR square, VB square is equal to VBR square plus VR square. So by using this, whatever the physical quantity you want, you can able to calculate. And next, if you see crossing the river in a shortest path, now this before in quickest path in the sense it takes very less amount of time, but this time what we are doing, okay, this time what we are doing, just we are crossing the river in very, oh, why I am getting always this one, yeah, right? Now this time this is a river, right? This is the river, and this time we are crossing the river in very shortest amount of time. In very shortest amount of time means we are crossing the river, this is vertical, and width of the river is L. Okay, width of the river is L. Here drift formula, we remember, right? What is drift formula? This in this direction there will be velocity of river, right? Here drift formula is equals to, let us see the drift formula. What is the drift formula here? Drift formula is drift is equal to VR minus VBR sin theta. What is that? VBR minus VR minus VBR sin theta, right? Excuse me. Yeah, let's see here. VR minus VBR sin theta. What is the VR minus, okay, VR minus VBR sin theta into L by VBR cos theta. VBR cos theta. Here, if you want to cross the river in a shortest path, not quickest path, in a shortest path, then what happens here? The drift should be 0, right? That is the main condition. If the drift is 0, this term will go this side, it will also become 0, and then finally you will remaining only one thing. What is that? VR minus VBR sin theta is equals to 0. From this, VR is equals to VBR sin theta, right? This is the condition for having condition for to cross the river in shortest path, means the drift is 0. Now let us see here, this is nothing but, just imagine, let me change the color, right? let me have white color now. Just what it is, this is nothing but velocity of VBR, velocity of board with respect to river, and this is x component, and this is horizontal component. Okay na? So now here you should remember, here this is nothing but velocity of board with respect to river, it is making angle theta, right? Then this is nothing but VBR cos theta, and this is nothing but VBR sin theta. What is this? VBR sin theta. Now here you should remember one thing. If this VBR sin theta, right? Now what is river velocity? This is the river velocity, right? I should greater. If this VBR sin theta become equal to river velocity, means what? This is your effort. In this your effort, the horizontal component is opposing the river flow, right? If these two become equal, then immediately what happens? Your drift becomes zero. Clear? That is the condition here, right? If it is VBR, then this is VBR cos theta. Then what is VR? This is VR, right? From this right angle triangle, whatever you want, you can find out. Okay na? From this right angle triangle, whatever the values you want, you can find out. And here you should remember that to cross the river in the shortest path, you should make a drift equal to 0, right? So these are the main important conditions or concept for the JEE Mains, right? And even advanced level problems also you can solve very well by using this concept. And if you have any doubts, please comment below. We'll continue in the next video by solving n number of important problems on these topics. Okay, thank you all. Thank you.